In this video, we will go over the limit comparison test. So yeah, limit comparison test. Suppose we have two series. Uh, two series. And if the limit as n approaches infinity of an over bn equals a positive tangential number, then either both series converge or both diverges. So here are some steps when we are doing limit comparison tests. You're given a summation of A of n. You need to choose or create the summation of B of n. Always choose create a P series or a geometric series. Take the limit as n approaches infinity. So of original over choice equals the limit as n approaches infinity of of A of n over B of n equals limit. And if the limit is positive and tangible number, so the limit has to be positive and a tangible number. Then step 3, then draw a conclusion. The original series of summation of an will do whatever your choice of summation of b of n does if the summation of b of n converges. And then the summation of a of n also converges. If the summation of b of n diverges, then the summation of a of n also diverges. So that looks extremely confusing, but let's do an example. So example 1 says determine if the series converges or diverges using the limit comparison test. So we have the summation of n equals 1 to infinity of n squared over 2 all over n fourth plus 5. So step 1, choose and create or create. So pick the biggest term on the top and pick the biggest term on the bottom. Pick. Okay, so we have n squared over n fourth, and that simplifies as 1 over n squared. So the summation of b of n is 1 over n squared, and that is our choice. Okay, step 2, we're going to write it as a limit as n approaches infinity of original over choice. Which equals the limit as n approaches infinity. And our original was n squared plus 2 over n4 plus 5 times it by the reciprocal of choice. And the reciprocal, our choice was 1 over n squared, so the reciprocal of that would be n squared over 1. So when you put it all together, it would be the limit as n approaches infinity. N squared times n squared is n4. And then on the bottom, n4 times 1, that's n4, which equals to 1, and that is positive, and it would be a tangible number. Okay, So we can say the conclusion is 1 over n squared, where p is equal to 2, is greater than 1. So this is, I believe it's a p-series, right? 1 over n squared can be expressed as 1 over n to the second power, since the summation of 1 over n squared converges, then the summation of n squared plus 2 over n4 plus 5 also converges. Okay, let's move on to example 4. So the summation of n equals 1 to infinity of 5 over 2n squared plus 4n plus 3. So first, we got to choose, I think we'll use p-series. Yeah, so we're going to choose. So choose the highest term on the top and the highest term on the bottom. So my highest term on the top is just 5. The highest term on the bottom is 2n squared. And I guess you can rewrite that as a p-series because that's the same thing as p over 2. You take out, factor out 5, 5 over 2, and then this is going to be 1 over n squared. So this is definitely a p-series. Okay, step 2 is the limit of n approaches infinity of, so you're going to do the original times the reciprocal of step 1. So our original is 5 over 2n squared plus 4n plus 3 times the reciprocal of our choice. What is the reciprocal of 5 over 2n squared? It is 2n squared over 5. So this is our original, and this is the reciprocal of step 1. Okay, so it's going to be the limit as n approaches infinity. And you kind of clean this up. The highest term is 2n squared. And then on the bottom, it's also the highest term on the bottom is 2n, or 5 cancels, so yeah. And then 2n squared over 2n squared is like 2 over 2, which is 1. 1 is technically a positive tangible number. So what we can say is the conclusion is five over two of 1 over n squared, the p-series, where p is 2, right? This is your p-value. If p equals 2, which is greater than 1, then you can say it converge. So you can say, so since 5 over 2n squared converges, then the summation of 5 over 2n squared plus 4n plus 3 also converges. Okay, let's move on to example 3. So example 3 says same idea, determine if this series converges or diverges using the limit comparison test. So we have, in example 3, we have the summation of n equals 0 to infinity of 1 over 3n minus n. So step 1, choose the biggest term on the top and the bottom. Or biggest term on the bottom. That is going to be 1 over 3 raised to the n. So the highest term on the top is 1, and the highest term on the bottom is not n, it's actually 3 raised to the n, right? And this concludes it looks like a geometric series. Or you can rewrite this as 1 over 3 raised to the n, right? And my r is 1/3, and 1/3 is technically less than equal to 1, but greater than equal to -1. So this converges. But we got to prove our other choice converges too, right? We got to prove our choice. So the choose converges, but what about the choice converges? So that would be the limit as n approaches infinity of 1 over 3 raised to the n minus n times, what's the reciprocal of, what is the reciprocal of that? It would be 3 to the n, right? Wait, so the one on the bottom is 3 over n, so the reciprocal of that is 3n over 1. Okay, so this right here is your original. And then this is the reciprocal of choice. So the limit as n approaches infinity of 3n plus 1 times 3n is 3n over 3n minus n equals, so when you plug in infinity, 3 raised to infinity is infinity. The bottom, it's going to be infinity. And you get an indeterminate form, so you have to use L'Hopital's rule. So basically, you just take the derivative of your numerator and the derivative of the denominator, right? So it's going to be the limit as n approaches infinity. And what is the derivative of 3n? 3 raised to the power of n? Well, it's going to be 3n times ln of 3 times the derivative of n, which is 1. And then what's the derivative of the bottom 3n minus 3 raised to the n minus n? It's going to be, well, we know that the derivative of 3n is this whole thing, so that's going to be 3n ln of 3 times 1. And then the derivative of n, or negative n, is negative 1. And when you plug in infinity, you're still going to get infinity over infinity. So you got to apply L'Hopital again. Okay, so if you take the derivative of this, it's going to be the limit as n approaches infinity of ln of 3 times 3 raised to the n times ln of 3 times 1. And then on the bottom, it's going to be ln of 3 times 3n ln times 1 minus 0. So this time, when you plug infinity, it's going to be 1. 1 is type 1 is a positive tangible number. Okay, so we can say that in conclusion, because 1 over 3n converges, then the summation of 1 over 3n minus n also converges. Okay, do one more example using limit comparison test. So example 4 says determine if the series converges or diverges using limit comparison tests. So step 1, choose the biggest term on the top and bottom. So the biggest term on the top is n. The biggest term on the bottom is not cosine square n, it's actually n squared. And if you simplify this, this is 1 over n, and we know that 1 over n is a p-series. So this 1 over n can be expressed as 1 over n raised to the 1, and our p is 1, which is less than or equal to 1, so we know it diverges. Step 2. Now we found that it diverges on the choose. Now do the one with the choice. We got to prove the choice also diverges. So that could be the limit as n approaches infinity of n. So your original, which is n over n squared minus cosine squared of n times the reciprocal of 1 over n, which is n over 1, and it spits out 1. So the limit as n approaches infinity of n squared over n squared, it gives you 1, which is positive, and it is a tangible number. And then you can say conclusion. It's the summation of 1 over n diverges, then the summation of n over n squared minus cosine squared of n also diverges. Okay, so that was the last example for limit comparison test. The next test we should do is integral test. So I will stop here.